Alright people, let's do two quick practice problems, get you primed for next class. Number 1, find the percent composition of sodium oxide. Okay, so I'm already going to fail this question if I don't know how to do my nomenclature, which is why it's so important to never forget your nomenclature. So before I can begin this problem, I need to know what the heck is the formula for sodium oxide. So as I look at this, I know I've got sodium, which will form the +1 ion, and oxide, which will form the -2 ion, which means that if I do my nifty crisscross method, the final formula for sodium oxide is Na2O. Okay, so the question now becomes, well, what percent by mass of this compound is sodium and what percent by mass of this compound is oxygen? As I take a look at this compound, I've got 2 moles of sodium. And as I think about how I'm going to determine what the mass of those 2 moles of sodium is, I have to go to my magic periodic table of the elements, discover that sodium is right here and therefore has a molar mass of 22.990 grams for every mole. And therefore my 2 moles of sodium is going to be 45.98 grams. If I do the same thing with my oxygen, I find that I have 1 mole of oxygen and that 1 mole of oxygen is going to have a molar mass of 15.999 grams. Therefore, 15.999 grams of oxygen in this 1 mole of sodium oxide. Alright, so our next step is to figure out, what's the molar mass of the compound. I've got 45.98 grams coming from the sodium. I've got 15.999 grams coming from the oxygen. Therefore, the total molar mass of this compound, 61.979 grams of sodium oxide. That's my molar mass. Okay, so I want to know, again, percent composition. I now know the part by mass of each of the elements and the total mass of the whole compound. So now it's simply a matter of taking the mass of the part, we're going to start with the sodium, over the mass of the total, and multiplying by 100. If I put that into my nifty calculator, 45.98 divided by 61.979 equals times 100. The percent by mass of sodium in this compound is 74.19%. Now, some of you geniuses out there can recognize that, oh, this compound is only made up of 2 elements. Therefore, if I know that the total has to be 100%, I can do some tricky math and figure out what the percentage of oxygen is right away. For those of you who may not pick up on that, we'll do the calculation here, but essentially it's the same thing. We just take 15.999, which is the part oxygen, divided by the same total, 979, times 100, to determine what our percent oxygen we have in this compound. So 15.999999 divided by 61.979 equals 25.81% oxygen. Always a good idea to box in our final answer here. So our percent composition by mass of this compound, about 74% sodium, about 26% oxygen. Couple of tips to keep in mind. Do these percentages add up to 100%? i.e., is the total percentage 100? Is the total of everything 100%? If it's not, you've done something wrong. Now, depending on how you round, it may or may not come out to exactly 100%, but it should be really, really close. We're talking like 99.99% or 99.98%, but anything beyond that, you probably want to check your work. Alright, so that was easy enough. Let's move on to number 2, where, oh my gosh, we have to read. It says, as some salts crystallize from a water solution, they bind water molecules in their crystal structure. Ooh, exciting. Sodium carbonate forms such a hydrate in which 10 water molecules are present for every formula unit of sodium carbonate. Find the mass percentage of water in sodium carbonate decahydrate, oh my god, nomenclature, which has a molar mass of 286.14 grams per mole. Alright, so let's tackle this sucker. Again, same thing. We are going to never be able to solve this problem unless we know our nomenclature. So as I look at this problem, sodium Na plus 1. Carbonates coming from camel in the Nick the Camel sentence is going to be CO3 2 minus, which means that my ionic compound is going to have a formula of Na2CO3. Feeling good about myself. However, it's a hydrate. It's a decahydrate, which remember, we are going to separate that hydrate, or the waters, from the ionic compound with a raised dot, deca 10 H2O. So here's my formula for sodium carbonate decahydrate. Now, we're looking for the mass percentage of water in this problem. And so as we look at this, we want to know how much water do we have in this whole thing. So what part water of the whole do we have? Now what's really nice about this problem, it's given us the molar mass. So we don't have to figure out what the molar mass of this thing is. We could just use what's in the problem. But if you doubt, challenge authority, always question. You can always go to your periodic table and bust out the mass of 2 sodium, 1 carbon, 3 oxygen, 20 hydrogen, and 10 oxygen. Put them in your nifty calculatora and check to make sure it comes out to 286.14 grams per mole. But since I'm going to try and save us some time here, we're just going to accept that this is in fact the truth and move on. So this problem is solved the exact same way. Note how I do this. I've got 10 moles of H2O in this compound that I'm trying to figure out the mass of. So I've got moles of water, grams of water, boom. Okay, now as I work to solve what the molar mass of this is, it's a compound, so I'm always going to go to my periodic table here. I find hydrogen, I find oxygen. I recognize here that I need 2 of these hydrogens and 1 oxygen because it's H2O. Easy enough, right? So let's put that into our nifty calculator. 1.008 plus 1.008, the mass of my 2 hydrogens, plus 15.999 equals 18.015 grams, 18.015 grams in 1 mole. I've got 10 moles of this stuff, so I'm not even going to use the calculator since I'm such a genius. And I'm going to move my decimal points. It's going to be 180.15 grams of H2O in 1 mole of this stuff. Okay, now remember, I'm looking for the percent water. So I know this is my part, so I've got 180.15 grams in my part over the whole, which is 286.14, 286.14 times 100. I'm going to bust out my calculator for this one. 180.15 divided by 286.14 equals times 100. Enter. 62.96% water. So this hydrate, a lot of the mass is coming from the water that's trapped within the ionic crystal lattice of this ionic compound. And so that, in a nutshell, is percent composition and percent composition problems.